All right, so now we're going to do doubling time. So this is kind of like if we had, the half time and double things before. We're doing doubling time, so we're thinking about doubling our money or investments. And so let's look at this. So how long would it take an investment to double? So if you started at 1,000, if you double it, you would go to 2,000. Or if you had $1, you're going to get to $2. So kind of thinking about it that way. And so under each of the following conditions. So we have interest is 4.3% compounded semi-annually, and interest is compounded 5% daily. So we're going to use the N is 365. All right, so what do we know here? Okay, well, semi-annually, that means N is 2 because we're going to do it twice a year, once after 6 months and another time after the 12 months. And so now we need to complete this by saying, okay, well, what is A? 4.3% compounded semi-annually, and we want it to double. Well, if we use the most simple thing here, I said, well, let's start with 1,000. If we double it, we get 2,000. Well, let's just say we have $1. Maybe we have $1 million, and we want to get to $2 million, even if we want to do that, and we just drop our units. Okay. Well, if we think about that, what is our formula? Well, we have that F of t is equal to our p, and then times, depending on what our compounding is, the 1 plus r over n to the nt. And so our P is what we start with, 1. Our F of t is what we end with, 2. So we can say 2 equals 1 times, and now we just plug in everything else we know here, okay? So 1 plus r, now our rate was 4.3%, so it's 0.043 over n was 2 raised to the 2 power times t. Now, t is what we're looking for because this is how long is it going to take. We want to solve for t. All right, so what do we do? Well, we remember back a long time ago, to get rid of this, we had to take the ln of both sides. And when we did that, we could bring that down in front. Now, we could divide both sides by 1, but when you divide by 1, it's there. So we can really think about that as being gone. And so let's just take the ln of both sides. And so we have the ln of 1 plus 0.043 over 2. And then that 2t, remember, that comes down front here. Okay, so it's gone up here. We have it down here. And we want to solve for t. So now let's divide by 2 ln 1 plus 0.043 over 2. And we also divide that side by it. 2 ln 1 plus 0.043 over 2. Okay? And when we do that, our 2's cancel here and our ln's cancel, and we're left with t. So let's go ahead and just write t equals, and now let's go ahead and plug that into our calculator. Now remember, semi-annually, we're going to have a similar kind of issue as we have over here because, we're going to have to think about what we get to get there when we get at the very, very end. So let's plug this into our calculator. Let's clear all that out. And so we wanted to take the ln of 2 divided by, and we want to take 2 times the ln of 1 plus 0.043, and then that was divided by semi-annually, so that was 2, and double the parentheses. So now that should give us our value. So we get 16.29 years, okay? Now, what is 0.29 years? Well, let's subtract our 16 and take that times 12 months. And so it's about 3.5 months. So 16 years, 3.5 months. So I'm going to write 16.29, and then I'll write the other way. So that's going to be roughly 16.29 years, or 16 years, 3.5 months. Okay. Now we want it to actually double. So we have to actually go to the next time we're going to get that interest, because here we've only got to the 16 years at this point, because remember, semi-annually is every 6 months, and so we're not going to get another interest until we hit the 6 months. And so this means we're actually going to have to be at, let's go ahead and put our years here, 16 years and 6 months. I mean, we're going to hit it at 3.5 months if we were compounding more often, but we're not compounding except for twice a year. So we're going to actually have to hit that second time to compound to be able to get that interest to make it to double. If we are at only that 16 years, we're not going to have enough to actually hit that doubling. So we actually have to go to 16 years, 6 months. Okay. All right, so the next one says we have interest 5% compounded daily. All right. So what are we going to do? Well, we're going to do the same thing. We're going to have 2 and 1. We're not going to worry about, 2 million or 2 what. We just want to double it. So we have 2 equals 1, and then it's going to be times 1 plus 0.05 now over our 365 raised to the 365 times t. Okay. Now this time, I'm going to use the calculator to solve it. I'm not going to actually solve it on my own with all the LNs. I'm going to show you how we can do this calculator based. So let's clear that so we don't have anything in the way. So we'll have math, then we'll use the arrow up, and we want the numeric solver. All right. So let's clear everything out here. And so what we have is on the left side, we just had 2. Now what do we have on the right side? Well, we had 1 times, but we can just get rid of that 1 times. And we'll say 1 plus 0.05 divided by 365 raised to the power, and it was 365 times t, but with our calculator we use x, so we'll call it x. Now to hit OK, we have to hit graph, and then we have to hit solve, so we have to hit graph again. And that gives us 13.86389. So let's go ahead and write all that down because that's quite a few, and I don't have that one. I'm not going to memorize it. 13.86389. That's good enough probably. And so now what we need to do is let's get out of this. And so if we take and subtract off 13 years, we had 0.8639 and times 365 days. So that's 315.3 days. Okay, so now we go back here and we found that t was equal to 13 years because we subtracted it off, and we had 315.3 days. Now remember, we're looking at whole days here, and to get to double, we have to go to the next one. So that gives us 13 years, 316 days. Okay, so we actually have to go to that next day to be able to say, yes, we doubled that interest completely. Okay. So these two, again, you had to think about what we had here, 3.5 months. Well, we're not at that semi-annual point, so we have to round it up to 6 months. Here we're at 0.3 days. We aren't quite there to get the double, so we have to round it up to 316 days, okay? And we also did it once taking logs of both sides and once using the solver in our calculator to do this. All right, so the next one. Here we have an investment to do, $5,000 we're going to invest, and we have 2 options. We have option A, which is 4.9% compounded monthly, so N is equal to 12, or 4.8% compounded continuously. So then we're going to use PERT, okay? All right, well, what it says on A is calculate the annual percentage yield for each option. What is the better option, or which is the better option? Okay, well, let's do that. And then how much would the 2 investments differ? Okay, so let's do that. So how do we calculate APY? Well, remember, APY for the monthly is going to be 1 plus R over N to the N minus 1. Okay, and then we can convert that to a percent at that point in time, or once we get this, we'll know it's like 1.042 or something like that, and then we can convert it to 4.2%. Well, let's do this. So we have 1 plus, now we have 0.049 over, monthly is 12, raised to the 12 minus 1, okay? Well, what does that give us? Well, let's calculate that. So we had 1 plus 0.049 divided by 12 and then raised to the 12. Now remember to arrow down so we're not subtracting 1 from the 12. And so that should give us our percent. So 5.01%. So let's use that. So we have 5.01%. All right. Well, for the other one, APY, well, remember on this one, we said that was e to the r minus 1. So here we're going to have e, now we have 4.8, so 0.048 minus 1. And we plug that into our calculator. So we have e to the 0.48, arrow down again, minus 1. And so we have 4.92%. Okay. So which is the better option? Well, it appears that one's the better option, APY, because when we get done with all the compounding, the APY considers all the interest you're going to earn. And so that one is higher than this one. And so that's the better option. Okay. So now B, how much do they differ? Well, now we actually have to plug everything in and actually calculate that. So for the first one, we'll have 3.5 years. So F of 3.5 is equal to, and now we're investing 5 grand, so 5,000 times 1 plus 0.049 over 12 times 12. Oops, better put that 12 a little better. Okay, to the 12, and then that's going to be times our years, so it's 3.5. And so that will give us the first one, and then the other one, f of 3.5, is going to be 5 grand again, and now we have e to the 0.048, and then times the 3.5, and so that will give us that one. So let's do both of those, and we'll write them down and see what we get. So let's clear that. And so the first one we had 5,000 times 1 plus 0.049 divided by 12 raised to the power, and then we had 12 times 3.5, and that should give us that interest, or that return. So 5933.35. Okay, and so now let's do the other one, which was 5,000, and then it was e to the r, which on that one was 0.048 times our 3.5. Now let me think. PERT looks good. So 5,914.68. As we can see, this one was a better return than this one, so we did have the right numbers. So now we just take 5,933.35 minus 5,914.68, and it's $18.67 better. All right, so the better, we know it was 18.67 more, and this one was 5,933.35, and this one was 5,914.68. Okay, and so then the difference was this. So that's how much more you would make on the compounding monthly at 4.9% versus 4.8% continuously. All right. So the next one here, we have Warren Buffett luncheon auction. So in June 2009, an eBay auction for lunch with Warren Buffett raised $1.7 million for the Glide Foundation of San Francisco. In 2009, Warren Buffett, an American investor and the second richest man in the world, had an estimated net worth of $37 billion. How long does it take $37 billion invested at an effective rate of 5.9% to earn $1.7 million? All right, so now we're kind of back to remembering effective rate. What is that value? Well, remember, that's when we get to the 1.059 because we have 5.9%. That's when we're there. The APY, remember, was equal to that effective rate minus 1, and then that would give us our rate here. And so the effective rate's 1.059, and depending on which one we had, in this case we're going to assume we're going to have the 1 plus r over n to the n. That's going to be our effective rate. We're assuming that. okay? And so what we need to have then is we need to think about what we need. So f of t equals p times, well, we know our effective rate, 1.059, and then that's going to be raised to the power t because we have to put a t here, and then we have to put a p here. So what are the f of t and p? Okay, well, P is going to be our 37 billion, all right? So that we'll just write as 37 billion, and so 1.059 to the T. But what is F of T? Well, that's how much it's going to be after we gain interest here. Well, I can't just do this on the top of my head. So 37 billion, there's millions, and that. So we have hundreds, thousands, millions, billions. Okay, so that's $37 billion, a lot of zeros. Now we're going to earn 1.7 million, so that would be at that point there. And so what does that equal? 37001700000. And so if we're putting it in the terms of this, that's going to give me 37.0017. All right. And so that's the number I need for F of T, because that's what I'm going to get from my future value, investing 37 billion with an effective rate of 1.059, and we don't know what T is. So that's what we're looking for. So guess what? We are going to try our calculator again. And so we'll go to math. We'll arrow up because we know it's the bottom one. Now we can clear that, and we said it's 37.0017, and this was the 37 times 1.059, our effective rate, raised to the power x. And we want to solve for x. We want to know how long. So we have to take graph, and so we get 8.01479937 times 10 to the minus 4. So we have to remember, there's something way out here we have to remember out there. So let's go back and think about how many days that is. So that's years. And so what we're going to have to do is we're going to have to multiply by days. So we're going to have to multiply that value, 0.0008014799 or something like that, times 365, and we get 0.29 days. In 0.29 days, he makes $1.7 billion on interest alone. Okay, so that's pretty mind-boggling. And so here we said that was equal to the 8.014799 times 10 to the minus 4, and that's years, or that's approximately 0.29 days. Okay, so a little over a quarter of a day, and he makes that $1.7 million. Okay, and so that's what we would do there. And again, we could have taken and divided first by 37, and then taken the ln of both sides, and then divided after that by 1.059, and we would have got our t, or we could do it like we just did it in our calculator, and we got the 0.29 directly. Okay. All right, so that's all I have for this section.